An atomic bomb exploded, and then something was created that no one had ever seen before. Not on Earth, not in a lab, not anywhere in the entire known universe. What researchers have just discovered amid the ruins of the nuclear inferno is absolutely unbelievable.
We are taking a very close look at this. Let's get started.
If you don't want to miss any more science news in the future, subscribe to the channel right now.
And for those who have already subscribed, you really helped the video with a thumbs up. 5,000 likes should appease the YouTube algorithm. Thank you very much, guys. But now we have the next exciting scientific topic again, so let's get down to business. August 6th, 1945, the Japanese city of Hiroshima.
Although World War II was no longer raging in Europe at that point, Japan continued to fight against the US and its allies in the Pacific. The US government hoped that the use of the newly developed atomic bomb would force Japan to surrender quickly and avoid an invasion of the main Japanese islands. On the morning of August 6th, the US bomber Enola Gay dropped the uranium bomb Little Boy on Hiroshima, which detonated at an altitude of about 600 meters above the city. 3 days later, a second atomic bomb was dropped on Nagasaki. On August 15th, Japan finally declared its surrender. The atomic bomb created a fireball in Hiroshima with temperatures exceeding 7,000 degrees. That is hotter than the surface of some stars. Within seconds, buildings, metal, glass, and earth, essentially the entire city, vaporized into a turbulent plasma cloud.
There are reports on YouTube from eyewitnesses who have experienced and survived the nuclear Armageddon. Listen to this.
At 8 o'clock, we started the morning assembly, and the man in charge of us, Major Yanai, was giving us a pep talk. You girls got a good training, and this is the very day you start proving your patriotism and loyalty to the emperor. We said, yes, sir, we'll do our very best. And at that second, I saw the bluish-white flash all over the windows. Next thing I sensed was just flying up in the air. I was just floating up in the air. The powerful blast flattened all the buildings in the city, and obviously my own building was falling down. My body was in it. When I regained the consciousness in the total darkness and silence, I knew what happened. I tried to move my body, but I couldn't, so I knew I was faced with death. Finally, Americans got us. Then all of a sudden, somebody grabbed my left shoulder from behind. Strong male voice said in the total darkness, "Don't give up. I'm trying to free you. Keep moving, keep pushing." And you see the sun ray coming through that opening and crawl toward it as quickly as possible. I looked back and saw the entire rubble was on fire.
That really makes you feel a bit queasy, and it's probably impossible to even imagine the full extent of the destruction. In that gigantic explosion, as we now know, something happened that was unfathomable even from a scientific perspective. Pure physics, but physics of the most brutal kind.
As that cloud cooled, the vaporized material condensed into tiny glass beads, which then rained down onto the ground, spreading across the entire region. And it is precisely these beads that are at the heart of our discovery today. In 2019, retired geologist Mario Vanier combed the beaches of Hiroshima Bay and came across tiny glassy particles in the sand. They were named Hiroshimite. Over the years, these tiny time capsules were closely examined by an international research team led by geologist Luca Bindi of the University of Florence. And that's when things got really exciting.
In total, the team examined 34 of these Hiroshima-It samples, scanned with electron microscopes and X-rayed with high-energy beams. In just one of these samples, they found a tiny metal grain, just 10 micrometers in size, thinner than a human hair. And this grain made the scientists' jaws drop.
The researchers found a mixture of iron, chromium, nickel, manganese, molybdenum, silicon, and aluminum, arranged in a crystal structure that has never before been documented anywhere on Earth. Thus, a completely new material structure has emerged from a remnant of the Hiroshima atomic bomb explosion, one that, as far as we know, exists nowhere else on the planet or beyond. In the other samples of Hiroshimite, the researchers did find plenty of iron-chromium alloys, presumably originating from the structural steel of the destroyed city, but most of them exhibited the relatively common, so-called body-centered cubic structure. Only this one tiny grain stood completely out of line. Like a microreactor, each individual molten metal droplet essentially froze its very own unique snapshot of the local chemical conditions at the very moment it solidified. Researchers refer to such materials as multi-component alloys.
Also mixtures of at least 5 metals, where each individual one is present in a significant amount, rather than just as a tiny admixture.
Normally, such alloys must be fused together in the laboratory under strictly controlled conditions. Temperature and cooling rate must be precisely calibrated. The atomic bomb also managed this process, only 1,000 times more chaotically and 1,000 times faster. And even after decades, a tiny grain just a few micrometers in size can still precisely capture the conditions that prevailed in the atomic fire for a fraction of a second.
So these particles are not ordinary melting residues, but true physical archives of the explosion. It's absolutely crazy when you consider that we are talking about a single blink of an eye in history, which is frozen to this day in the crystal lattice of a metal grain.
Structurally, the new alloy belongs to a family known as the AIAU4 type, an ordered variation of the so-called beta manganese structure. It's quite complicated, but the key point behind it is simple. This structure has never before been observed in connection with such a chemically complex mixture of so many different metals. So the researchers essentially had to open a completely new chapter in the alloy textbook.
One might ask oneself now whether this alloy can really be so unique, or whether it could have already existed somewhere else in industrial materials. The researchers checked exactly that and ruled it out. The chemical composition deviates so strongly from the usual, and the crystal structure is so specific that an origin from pre-existing materials is impossible. This alloy was actually only born through the bomb.
Materials scientist Michael Wedham of Carnegie Mellon University sums it up: if you're looking for new materials, you have to look for them in unusual places. It hardly gets any more unusual than in the sand of a bay where an atomic bomb once exploded, although one idea would be to look for such materials in space, and that's exactly what Luca Bindi and his team have already done.
Quasicrystals are materials in which the atoms do not repeat in the same way as in ordinary crystal structures. About 10 years ago, we discovered them in nature when we examined a fragment from the mineralogical collections of our university museum. Analysis of this sample, as well as other fragments found during an expedition to the remote regions of Siberia, showed that all these fragments were in fact part of the same meteorite, meaning they were extraterrestrial objects. We then wondered whether it would be possible to prove this hypothesis, namely, that these materials could have formed during collisions between asteroids in space. That is why we began a collaboration with Caltech, which has a laboratory capable of simulating asteroid impacts. Incredibly, and to our surprise, we succeeded, on our very first experiment and attempt, in reproducing a quasicrystal with the same structural perfection and the same chemical properties. For this reason, we began to consider that the material produced during the first nuclear explosion, the so-called Trinity test on July 16, 1945, the culmination of the Manhattan Project, might be the right place to look.
And it was precisely this consideration that led to another incredible discovery in connection with nuclear weapons tests. Bindi and his team had, as he mentioned, already discovered something previously at the site of the very first atomic bomb test, the so-called Trinity test of 1945 in the New Mexico desert.
The Trinity test took place on July 16, 1945, and was the first successful detonation of a nuclear weapon ever, just a few weeks before the atomic bombings of Hiroshima and Nagasaki. The plutonium bomb, nicknamed Gadget, exploded atop a steel tower about 30 meters high and released a blast equivalent to approximately 21 kilotons of TNT. The intense heat fused the desert sand with material from the tower and the bomb into a greenish glass that was later named Trinitite. And decades later, researchers discovered in this very Trinitite another structure that can hardly form under normal natural conditions, an unusual quasicrystal, that is, a material with an ordered structure that never repeats exactly. Together with the new discovery from Hiroshima, a rather fascinating pattern is emerging. Nuclear explosions seem to be systematically capable of opening up entirely new and unexpected realms of materials that we would otherwise never see.
Pretty cool, but it has the downside that you first have to detonate an atomic bomb for it. And for science, this is more than just a minor curiosity. Multi-component alloys are currently very popular because they can combine properties like hardness, corrosion resistance, and stability at extreme temperatures in a way that is hardly achievable with classic alloys.
The newly discovered structure could now even serve as a blueprint for researchers to specifically recreate similar materials with comparable properties in the laboratory. Of course, this time without an atomic bomb, and the study of deposits such as those from Hiroshima also helps researchers in the field of nuclear forensics learn more about the exact conditions and materials involved in past detonations. This knowledge remains crucial for fully understanding the effects of such weapons and preventing them in the future. Or, as the researchers summarize in their study, high-energy nuclear detonations create extreme, short-lived physicochemical environments in which previously unknown materials can form. This finding demonstrates that nuclear plasma events can stabilize complex metallic phases and highlights the debris from a nuclear explosion as a natural laboratory for the formation of non-equilibrium alloys and the discovery of new materials.
So, these little glass beads are far more than just a scientific footnote. They are silent witnesses to one of the most consequential seconds in human history. I will keep you updated on all further discoveries in this field, so feel free to subscribe to the channel now and don't forget to hit the like button so we can crack the 5,000 likes mark. And while we're on the subject of gigantic, barely imaginable things,
did you know that researchers are currently observing a structure over 8,000 kilometers long in the middle of the Atlantic Ocean? It's a real monster that's even visible from space. The so-called Great Atlantic Sargassum Belt just keeps growing and growing, and you can find out what it's all about in the video up in the top right corner. Be sure to check it out, it's super exciting. As always, you'll find another topic related to science and space in the bottom right corner. Otherwise, I'd say see you in the next video. Take care, everyone.